Hello, students of the London School of Science and Technology. My name is Jeremiah Johnson, and I'm a professor in the Department of Chemistry at MIT. It's really nice to virtually meet you today, and I hope that you're all staying safe. Today, I'd like to tell you a story about polymers. So what are polymers? Polymers are large molecules composed of smaller repeat units connected together, kind of in a long string, like a beaded necklace. Except a beaded necklace that's about 1 billion times smaller than your typical necklace. So why do we care about polymers? Well, they're key components of materials that you use and interact with on a daily basis, including plastics, rubber, such as on automobile tires, textiles used to make clothing, paint, coatings, food packaging, etc. In fact, you are made of polymers. DNA, RNA, proteins are all polymers. And these are the molecules that give rise to the unique functions that enable life. So hopefully you'll agree with me that polymers are really amazing materials. But unfortunately, we as a society are facing major challenges related to polymers. Namely, because of their great utility, polymers are literally everywhere. In fact, it's estimated that about 300 million tons of plastics were produced just last year. And this number is increasing rapidly. In fact, in the next 15 years, so by the year 2035, it's estimated that humanity will generate more plastic than has been produced in all of previous human history. Right? So this is indicative of an exponential increase in plastic production. And in fact, while most of this plastic can be collected and stored in landfills, the vast majority of it is not able to be reused or recycled. In fact, only about 8% of all plastics are recycled. Moreover, a significant fraction of plastics escape to the environment, and this has led to the formation of large deposits of plastics in the ocean. In fact, it's estimated that by 2050, so in 30 years, there will be a greater mass of plastic in the ocean than fish, which I think hopefully would motivate us to want to solve this problem and ask, how can we use and reuse plastics more responsibly? Now, so what's the problem with most of these plastics that we use? Well, they're made from polymers, as I've already noted, and these have really great properties, but the problem is that they last a really, really, really long time. In part, we want them to last a long time so that we can use them, but a lot of polymers, when they're exposed to the environment, can last there for hundreds of years without breaking down, and this leads to the accumulation in the environment. And as I mentioned before, you've all heard of recycling, but such a small fraction of plastics are actually recycled. Why is this the case? Well, in part, it's economics. So in many cases, it's just not cheap enough to recycle a material. It has to do with sociology. In many places, plastics recycling is just not common practice. It's not part of culture. But it also has to do with chemistry and basic science. And considering how to design polymers to undergo chemical reactions that would allow them to be broken down more easily. And so my research group at MIT comprises a team of chemists focused on developing new ways to make better polymers. And this is what I'd like to tell you about a little bit today. So in our new research, we're focused on one of the hardest problems in polymer recycling, and that's a class of polymers called thermosets. So what are thermosets? So they're the materials used in many of the most demanding applications today, such as for airplane and automotive parts, construction materials, windmill blades, adhesives such as epoxies, and many other spaces. And thermosets are used in these applications because they're extremely durable and strong. They're able to resist chemical degradation and really high and low temperatures. So they're just very, very stable and robust. But these features that make them so stable also make them nearly impossible to recycle or to reuse. And this is because they're made of a large number of individual polymer molecules or macromolecules connected together by covalent bonds. And which you probably know, covalent bonds are the strongest bonds around, meaning it takes a lot of energy to break them and degrade a thermoset material. As a result, thermosets, while they comprise about 20% of all polymeric materials made today, almost none of them are recycled or reused. It's almost impossible. So in our recent publication from my research group, we reported an exciting discovery that offers a new way, a new strategy to recycle thermosets. And we can do this using a new type of molecule we call a cleavable co-monomer. And we show that it is possible to use our cleavable co-monomer to form industrial thermosets with identical physical properties such as stability and mechanical strength compared to the original thermoset material. But now the material has an added feature of being able to be degraded and recycled under very mild conditions. Our cleavable co-monomer can be produced at low cost, meaning that could potentially be used in today's thermoset manufacturing. And additionally, the conditions we need to use to degrade and recycle our plastics, our thermosets, are quite mild and allow for an outstanding degree of control over the degradation process. And this means that manufacturers could collect materials made from our cleavable co-monomers and easily break them down to produce new materials with the same outstanding properties as the original. So while humanity has a long way to go to address the plastics pollution challenges and other major climate issues, we hope that our research will represent a small step forward toward the practical recycling of materials that are otherwise considered impossible to recycle. So I'd like to thank you very much for your time, and I encourage all of you to learn more about the issue of plastics pollution and plastics recycling and think about ways that you can help out every day. Just to start with, you can try to use less plastic and be sure to wash and sort the plastics that you do use so that they can have the best chance of being recycled. But beyond that, if you're a scientist or a sociologist or whatever your skill set or focus may be, I encourage you to apply it to thinking about this major challenge. And I'm optimistic that if we work together, we can achieve a greener and better future for generations to come.